ball of mass 150 grams is hit horizontally from the top of a 40-meter high cliff with a speed of 25 meters per second. Using g equals 9.8 and ignoring air resistance, calculate the following values. So firstly, we're going to calculate the time the ball takes to land. So what's the first thing we do? Draw a diagram. So let's draw a diagram. We have, there's a cliff. There's our golf ball. We know our cliff is 40 meters. And we know our speed initially is 25 meters per second. And we know our acceleration as well. What's our acceleration? 9.8. Good. Okay, now here is where I would suggest the second step comes in. Write down the values that we know in terms of our Suvat equations. Okay. Now, in this case, we want to calculate the time the ball takes to land. The only way we're going to be able to do that is by considering the vertical path. Because remember, if we hit the ball or if we drop it, it'll take the same time. So let's consider the vertical axis. So, in our vertical axis, let's have a look at what we know. Do we know the ball's initial speed? Vertically, what is it? 0. Good. It's horizontal 25, but it starts moving vertically at 0. Okay? So it starts off basically at rest in the vertical plane. So our initial is 0. Do we know our final vertical speed? No, we don't. So let's not worry about that. Do we know our acceleration? 9.8. All right. So here is where we can look at this and say, right, let's consider down to be positive, I think. The ball's traveling downwards, so let's consider down to be positive and up to be negative. Okay, so in that case, our acceleration is downwards, so it's positive. All right. Do we know, what else? Do we know time? No, we need to find time. So let's write down, so it's always good to write down what you know and what you want to know. Okay, we need time. Do we know the distance vertically? Yes, good. Distance vertically is 40 meters. Okay, so by looking at this, all of this is in the vertical plane. We've got 3 values that we know. So that means we can find the last one. Okay, so, well, the best thing to do at this point then is to look at the letters you have written here and find a Suvat equation that involves them all. Okay, now, okay, here's a little trick I'm going to show you. I said at the start of early commencement that you'll never have to do anything beyond Year 9 maths in this room. Okay, I mean that too. So, the formula we need, ut plus 1/2 at squared. Now, solving for t, that's a quadratic, which is beyond Year 9 maths. So I'm going to say, let's not do it that way. We've got any 3 values, we can work out the other 2. Let's work out the other one. So, v is equal to u plus at. All right? We know, and this is our speed as it hits the bottom. Okay? As our ball just hits the ground, we're going to work out the vertical speed. So v is equal to u, which was 0, plus, oh, hang on, we can't do that, can we? We don't know t. Oh, what am I doing? All right. So in that case, let's do v squared equals u squared plus 2as. Can we do that? 2as. Yes, we can. Let's do that one then. Sorry? No, it's just a square root. So, v is going to be equal to the square root of 0 squared, which is 0, plus 2 times 9.8 times s is 40. So our speed at the bottom is going to be 28. So that's just our vertical speed. All right, so our vertical speed when we hit the bottom here is going to be 28 meters a second. So we've got our final speed. So now we can use this much friendlier equation. Now we can solve this for t. So v minus u equals a t. So then t would be equal to v minus u on a. Okay, so v minus u is going to be 28. So 28 minus 0 divided by 9.8. Our time is going to be 2.86. Okay, it's a bit of a mess, but there is our answer. So let's think about the common sense rule. Does this seem to obey the common sense rule? Does it sound about right that it would take nearly 3 seconds to fall 40 meters? Sounds about right to me. Yeah. If you get 15 minutes, you've gone wrong somewhere. All right, but yeah, 3 seconds sounds about right. So we've got it. Calculate the time that the ball takes to land, 2.86 seconds. All right. Okay, part B. Calculate the distance that the ball travels from the base of the cliff, i.e. the range of the ball. So what we want to work out here is, if our ball goes like that, we want to work out that distance. Okay? Now, here is where people go wrong. In the first example, we were only working in the vertical plane. Here, we're looking for this distance. We can only work in the horizontal plane. Okay? The number of times I've seen people try to work out something horizontally and using the distance from the height of the cliff, never do that. You are either working horizontally or vertically. You can never do both at the same time. Don't get them mixed up. So here we're working horizontally. So if we're working horizontally, we know there's no acceleration. So our speed is equal to distance over time. We're looking for our distance. All right, so let's rearrange and we get distance equals vt. Do we know our horizontal speed when it hits the water? 25. There is no change in horizontal speed. Okay, horizontal velocity is constant. Do we know the time it takes to hit the water? 2.86. The same as it does to fall vertically. Okay, it can't spend extra time moving horizontally compared to vertically because it's just traveling in that path. So we know the speed and the time, so we can work this out. So the distance will be 71 meters, 71.4 meters.
What? If you're doing 75 times 2.86. Yeah, but if you're doing all extra decimals.
Yeah, I used all the decimals. I just left it in my calculator.
Yeah.
But okay, so good rule of thumb on an exam: if you're within 5%, you're fine. So if you put either one for there, if you have 71.3, 71.5, you're fine. Okay, no issue. Just on an exam, make sure you show you're working so the examiner knows what you've done. Okay, there we are. We know that. Calculate the velocity of the ball as it lands. All right, so remember, velocity, we're going to have two components for this. So for our velocity, our ball is going to be traveling something like this. So we want our hypotenuse here. We have our horizontal velocity, we know is 25. We worked out the vertical velocity earlier, didn't we? What was it, 28? Yeah. 28, good. All right, so this is nice and easy. We've got our two values, so we can use Pythag to work this out. We all remember Pythag, right? Year 9 maths? Okay. 25 squared plus 28 squared. Square root of that. So I get 37.5 meters per second. So there is the magnitude of our velocity. Now we need the direction. So if we work out that angle in there using trig, okay, so personally, now this is my personal opinion. You can feel free to do it however you like. I prefer to calculate things like this using the data I was given, or that I have the most faith in, right? This 37.5, I don't know, all right? Not sure. Let's use the 28 and the 25 and just work out the tangent. All right, so tan theta is equal to opposite on adjacent. So theta is going to be equal to the inverse tan 28 over 25, which is 48.23. 24, thank you. 48.24 degrees. So we would say this, the velocity of this ball would be 37.5 meters per second at 48.24 degrees below the horizontal. Okay, because remember that angle is the same as that one in there. So it's 48.24 degrees below the horizontal. All right, there are two components. We've got the magnitude and the direction. We're done. So remember those key steps. Draw a diagram. Write down all of the information you know and what you want to know. Make sure you're only working either in the vertical plane or the horizontal plane. You'll probably need to start in the vertical because you'll need the time. Okay? From there, as long as you don't mix up the vertical and the horizontal, you should be okay. Any questions? Anything here you're not sure about? Pal?
How do you know when to use the vertical?
So just consider the direction that, I guess it's what comes in, what you know the most about, I guess. So in this example, in the first one, we wanted to work out the time. But in the horizontal plane, we had no way of working that out because we didn't have the distance horizontally, and we did have the speed, but we still had two unknowns. Okay? So you had to use the vertical one there because you could do that with only one unknown. Does that make sense? That's the best example, best advice I can give you, but it comes down to practice. You will learn when to use each plane. Okay? Any other questions? All right, I'm going to give you a few minutes. Have a go at the next one. See how you go.